Okay, so the vomit comet is the nickname of a jet used to simulate zero gravity for astronauts. To simulate zero gravity, the jet flies in a parabolic arc starting at an altitude of about 7,300 meters. After climbing for about 30 seconds, the jet reaches its maximum altitude, about 9,800 meters, where the weightless effort occurs. The jet descends back to an altitude of 7,300 meters, about 60 seconds, and then repeats the process. Sketch the parabola. So what do I have here? Reading this the first time, you might not understand everything, right? You might have to want to read it again, right? And then you want to split the information down, slice them, right? Slice your information. So the first sentence is just an introduction. There's nothing to it. That zero gravity name is just a name, okay? It's just introducing the name. So the second sentence is where information are given to me. So I'm going to read that. To simulate the zero gravity, the jet flies in a parabolic arc, starting at an altitude of about 7,300 meters. What does that mean? So starting the initial, which means what is the time at that point? 0, right? So at time 0, what is the height of that jet? 7,300. So my first point is the initial point, right? Because it says, right? So my point right here is 0, 7,300. Right? Because my initial time is 0. Good. After climbing for about 30 seconds, the jet reaches its maximum altitude of 9,800 meters. So another important information there. What is it? The vertex. Where's the vertex? At what point? 30, 9,800. Yes. How do I know it's a vertex? What word gave? It gave the word maximum. See, you guys are problem solving right there. Okay? So it's telling you it's a maximum. That means it's the vertex. Perfect. So far I have 2 points, right? My initial point, my maximum point. Then it says where the weightless effort occurs, and then the jet descends back to an altitude of 7,300 meters, about 60 seconds, and then repeats the process. So what's my third? 60 and 7,300. And that would be, do you guys understand that this is symmetrical to this? Right? So the 60, 7,300 is a symmetrical point to the 0, 7,300. Right? Because they have the same y value, and they're exactly the same amount or distance away from the axis of symmetry, which is at 30, right? So graphing this, I can graph it just by trying to be able to fit some of it, right? It's going to be approximate, right? You can go up by 2,000 if you want, because my highest point is going to be 9,800. So let's go by 2,000. 4,000. Let me see. Do I need to go by 2 or 1? 1, 2, 3, 4, 5. Yeah, I could go by 1. And then something important that I forgot to mention earlier is labeling your axis. Oh, I did not do that in the previous question. That's a wrong thing to do for me from my end. So I should label my axis. Guys, what I do on the board here should be things that you do when you do your homework, when I evaluate you, right? Or when I assess you. It's things that I expect from you. Okay? So if I want to name this axis, what would I name it? What is it? Height in what? In meters. So labeling is very important, and then you're going to include your units. Usually we include our units in brackets, that indicates a unit. Even if you're doing like bio, or if you're doing chem, or if you're doing physics, you're going to have to do that as well. Good. And then what do I put on my x-axis? Time in seconds, right? So time in seconds. Good. And then it looks like I can fit 10, 20, 30, 40, 50, 60, right? I can do that. If you don't want to include all the values on the x-axis or on the y-axis, that's fine, as long as I can see a scale, right? If I understand that this is, if you do this, I understand that this is 10, 20, right? But if you don't write anything, how would I know that you're going up by 10? Why are you not going up by 20? Or why are you not going up by 60? How would I know, right? So that's why I need a scale. Okay, now my first point is at 0, 7,300. So 7,300 is about here, and then 0 is about right here. My max is at 30,9,800. So it's about, oops, that's the 10,000. A little bit lower than that. And then 60. If you guys see that I'm doing something not right, please let me know, because I can't see close. I feel like this is a little bit shifted. Do you guys feel that too? No? No? And then that's the graph. Do we understand that? Yes, you can. Yeah. So some people like to, so you can start your graph, like let's say if you want to start your graph at 7,000 and then you want to go up by hundreds, let's say, right? You can do that, but you have to put a squiggly line or a zigzag line at the beginning. So that means you're omitting the other points. They are still there, but you're not showing them, okay? So this way people, instead of starting with 1,000, you can start with 7,000, 7,100, 7,200, 7,300, and so on and so forth. But if you do that, you have to include, you have to put like a zigzag thing on your axis. Okay? All right, which makes the graph look nicer and more accurate. Now, the second part is to find the equation. So write a quadratic relation to model the path of the jet. The parabola also passes through the point 319799.9999. So what's the question asking me for? Quadratic equation, right? Quadratic relation. So y equals ax minus h squared plus k, right? Yeah, that's what quadratic relation is. It's basically finding the equation. Do I have enough information to find it? Okay, where do I start? H and k, which are what? What other information do I know? Do I know A? Or do I have to solve for A? I have to solve for A. How do I solve for A? So I have to plug in something for y and x. What do I plug in for y and x? We already have 2 points, and they gave me another one, right? So there's 3 points to pick from. Technically speaking, because they gave you this point in this question, they want you to use that one. If you use the other one, is it going to be wrong? No, right? But because they gave you this, they're expecting you to use this, okay? So that means I'm going to use x and y into my equation. Plug in y. This is not a fun number to plug in, just so you know. BEDMAS says I have to do the brackets. So it's going to be 1, and I'm going to do the square right away, right? 1 squared is 1, right? So if I do the bracket, which is 31 minus 30, that's going to be 1. And then if I square it, that's going to be still 1. Okay? So I'm going to just not write that, or I can write 1 on the right here, right? I don't have to. Okay? And then plus 9,800. Now, what am I supposed to do? Move what? Move the 9,800 over, and then if I move it over, what do I get? Minus 9,800. That's supposed to be a 9. Equals to A. And that should supposed to be 0.001, I think. Uh-huh. And how did you know that this is not right? I'm looking at my answer. I'm like, something's not right. Uh-huh. Right? So after you look at your answer, I did it in my head. I didn't even realize that, oh, it's negative, right? But I was looking at my graph. It's opening down. So that means my A value has to be negative. Go back and check your work. Right? How many of you got this right? Got the question right? Part of the question, right? The graph, right? I'm asking you guys. Okay. Equation? You didn't try it? Okay. Good. So, the effects, part C, the effects of simulated zero gravity start being felt at about 20 seconds. What is the jet altitude at this time? So what do I know what they're asking me for? I know the time. Okay, and then what do I do with this time that's given to me? To find the height, I have to plug in the time. Which letter represents time, X or Y? X, because X is on the X-axis, time is on the X-axis, right? So time is right here, so time represents X, right? So I know that this is X, plug it in, solve for Y. Yeah? So Y equals negative 0.001, 20 minus 30 squared plus 9,800. But math tells me I have to do brackets first. So that's negative 10 squared plus 9,800. Negative 10 squared is 100. And that's going to be negative 0.1 plus 9,800. And that means it's going to be Y equals 97.999.9. Because that's a word problem, I have to write a therefore statement. Okay? So therefore, the altitude at 20 seconds is